Now let's create our method to remove a vertex. So let's bring this up. We're going to remove the D vertex. But before we can remove that vertex, we have to remove all of the edges that vertex has with other nodes. And it is only then that we can remove the vertex. So let's bring this back, put our edges back like that. And this is what that graph will actually look like. So I had mentioned in the Big O video that there would be an efficiency that we could use in graphs that have bidirectional connections. And the efficiency is contained in this list. We know that if D has an edge with another vertex, that vertex also has an edge with D. So for example, right here, this edge that D has with A lets us know that A also has a connection back with D. So in a moment, we're going to create a for loop that just loops through this list. And the variable we'll use in the for loop will be called other vertex. So in this iteration of the for loop, other vertex is A, and we'll go through its list of edges and remove D. We'll cycle through the for loop again. Other vertex is B. We remove D from that vertex, and then we'll do that for C as well. And now that we've removed all the edges, we can come down here and remove this vertex. So let's say we had a situation where the graph had 1,000 vertices. We would only have to go to these 3 to remove edges with D. And that is a huge efficiency. So our graph now looks like this. We've removed the edges and we have removed the node. Okay, so now let's start coding this. We'll say remove vertex and we'll pass it the vertex that we're going to remove. And the first thing we need to do is make sure that vertex actually exists in our graph. And if it does, we will use this for loop to go through that list of edges associated with D. So then we'll go to that other vertex and remove the edge it has with the vertex that we're trying to remove from the graph. Okay, so this part here, once again, is going to do this. Other vertex is A. We remove the edge. And then we're just looping through this list of edges. Now that we're done with this, we can remove the vertex itself. We will delete the vertex D. And that's going to look like this. And now our graph looks like this. We do still have a couple of lines of code to add. If we have gone through this whole process here and removed all the edges, remove the vertex, we will return true. If the conditional in this if statement equated to false, we will skip all of this and return false. So we'll look at this code in a moment in VS Code. And when we do, we will build this graph, and then we will remove D. And then we'll print it out. And when we print that out, it should look like this. All right, so let's flip over to VS Code. So there is the remove vertex method there. And I'm just going to scroll this up, and then I'll move this over so we can zoom in on this. So we'll create a graph called my graph. And these lines here create our 4 vertices, A, B, C, and D. And these create all of the edges that we had in the diagram. And this will print out our graph. So I'll run this. And that gives us our graph before we have run the remove vertex method on the D vertex. So I'm going to come up here. I'm going to paste in this line of code. And that's what's going to remove our D vertex. Then we will print this again, and D should be gone, as well as any edge that connects to D. So I'll run this, and this is exactly what we would expect. All right, that is our method for remove vertex.